Okay, today in IM2 we're going to talk about similar right triangles. So here we go. Okay, you'll notice that they have a right triangle similarity theorem. And if an altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So you have your original triangle, which is triangle ABC, and then you have these two other triangles that are formed. It has to be an altitude, which means it has to be 90 degrees, and then all of these triangles are similar. Okay, we're going to use that in our next slide. Okay, so we're going to start by identifying similar triangles, and it's important that you be able to look at a set of these kind of triangles and identify what the similar triangles are. So the first thing I'm going to do is write my original triangle, which I'm going to call RST. Okay, so that is the big triangle, the biggest one. Then I want to make it similar, and I'm going to do this triangle. Now what I want you to notice is that you need to make sure that you have your corresponding sides in the same order. So if you notice, this is the hypotenuse of the big triangle. So look for the hypotenuse, which is the one across from the 90-degree angle, and that is RT. So I'm going to put RT there. Okay, now make sure that it's all corresponding, and then my last point is U. Okay, now I'm going to do the next one, and I'm going to do it in a different color so that you can see the difference. Okay, I'm going to do triangle. Look at your little triangle. Remember, this is a 90-degree angle. So ST is my hypotenuse, but I'm going to write it TS because that is how it would correspond, because I'm going from the pointy end to the other end. So see how RS and then RT. Okay, so you want to make sure you've got that right, because these have to also be similar. And if you notice, ST is the short side of the triangle, and TU is the short side of that triangle, and then SU is the short side of the triangle. So that's another way to look at it. So when you're dividing these triangles up, you can look at the hypotenuse, the long leg, and the short leg. And that will help you be able to put these in order. So the long leg here for the biggest triangle is RT, okay, long leg, which is for the biggest triangle. The long leg of this triangle is RU, and the long leg of this triangle is TU. So you need to be able to identify those when you're doing this. So here's the three triangles, and there's the statement. They did it in a different order than we did, but I always like to start with the original triangle. Okay, so now we're going to do a problem from the journal. Now this problem isn't my favorite because these triangles look awful lot alike, and it's really hard to tell which one's which. But as long as you remember to use your right angle to find your hypotenuse, okay, so there's my hypotenuse, and this is the hypotenuse for the original one, you should be able to calculate the similar triangles. So I'm going to let you go and try it, and there's the answer. Okay, so notice again, HI is my hypotenuse, okay, and then for this one we have JH is a hypotenuse, and we have IJ is a hypotenuse. So we're in good shape. Okay? Alrighty. Okay, now we're going to learn about the geometric mean. The geometric mean of two positive numbers A and B is the positive number X that satisfies this. So then you cross multiply, you get this, and you get this. Now, we're not going to do a lot of work with just the geometric mean, but we're going to use it to solve things in the kind of triangles we just talked about. But if they ask you to find on your homework the geometric mean of two numbers, then you just apply what you just learned. So you would say x squared, and there it is. I forgot that I had written it down. So this is all set up for you. You would say x squared equals a times b. You put those two numbers, then you do the square root, And they simplified it. They didn't even multiply it out. They simplified it, and that's how they got the geometric mean. And then you could calculate it here. Okay? So read that over a couple times if you need to understand a little more carefully. Now we're going to apply it to our triangles. All right. So the geometric mean, called the altitude theorem, is using the altitude. Okay? So the geometric mean is the piece that is shared by the three triangles. Okay? So what you're going to do is you're going to see that CD is part of all three triangles. But in this case, look at what it's doing. It's saying CD squared equals, and this is the altitude. That's why it's called the altitude one. And then you're looking for the altitude of the other two. Okay? So all of these are altitudes. So you've got CD squared, that's this one, equals AD, that's this one, and BD, that's this one. Okay? So when you're looking at this formula, it's set up like that. This one is part of both triangles. So, and if you look at it, I'm going to teach you a different way to look at it in a minute, but just look at what parts of each triangle. So we're talking about the little triangle and the median triangle in this case. Okay, but it can be applied to all of them. Okay, the geometric mean leg theorem is when you use the legs. Okay, so we've got CB squared, that's this one. Okay, and it equals DB, that's this one, and AB, that's this whole one. Okay, so what we're talking about here is the segment that's closest to it. Okay, so CB is equal to DB times the whole thing. Okay, and AC, which is this one, is equal to AD, which is this one, times AB, which is the whole thing. Now, I think these are kind of confusing because I learned them a different way. But if you want to memorize those, go ahead. So I'm going to show you the method that I learned, which is also written up. Okay, so read this carefully, and then you'll understand what we're going to be doing. So the reason I like this method better is because it's looking at the relationships of the pieces of the triangles. So what I do when I get a problem is I look at what this is. CD is to AD. So here is CD, and here is AD. They are part of the same triangle. CD is the short leg, and AD is the long leg. Now, when you set up a number to be set up a side to be the geometric mean, then that means it has to be the long leg in the other triangle. And sure enough, for this triangle, CD is the long leg, and BD is the short leg. And now we've set them up so that we could solve if we were given three of those pieces. And you can see here, it gives you one of those formulas that we just went over. Okay? All right. Now for this one, and this is the altitude, so this one would be the altitude theorem. But I like doing it this way anyway. Okay, so now we're going to do another one. I'm going to do it in a different color so we can see the differences. So look at CB and DB. Okay, so CB is right here and DB is right here. So as far as this triangle goes, CB is the hypotenuse and DB is the short leg. Okay, so now is CB the short leg of any? Yeah, it's the short leg of the giant, the biggest triangle, this one here. So now it's the short leg, and I need the hypotenuse of that big angle, and there's AB. Okay? So you have to make sure that whatever you put here is the same. Okay, let's try one more and do one more color. All right, so we're going to look at AC and AD. So AC is right here, okay, and AD is right here. Whoops, AD is right here, sorry. Okay, so AD is right there. So this is the hypotenuse, and this is the long leg. Okay, so I'm going to say AC is my hypotenuse, and this is my long leg. And then I look at AC again. Where is AC, my long leg? So AC is the long leg for the biggest triangle, the one that goes like this. Okay, so now we're going to use that one, and if we look at the hypotenuse of that one, it is AC. AB, I mean, sorry. So that is the hypotenuse, and AC is my long leg. And notice when you cross multiply, these are the geometric mean leg theorem. Okay, so if that helps you set them up better, go ahead and use my method. Otherwise, you can use theirs. Okay, so we're going to use both methods when we do this. So here is how you would use the geometric mean. First, you have to recognize which two triangles you're talking about. So this X has these two triangles in common. Okay, so that's what you want to make sure that you're looking at. So x squared equals 6 times 3, and you solve it. The value of x is 3 squared root of 2. Now, how I would set it up is the first thing I would look at is, okay, x is the short leg of this triangle, and this is the long leg. But of this triangle, it's the short leg. No, it's the long leg, sorry. It's the long leg, and this one's the short leg. So now I know that I can set it up short to long or long to short. Doesn't matter. So I'm going to set it up long leg to short leg. And so I'm going to do the first triangle where x is the long leg, would go to 3 is the short leg. And then I would do x is the short leg down here, and 6 is the long leg. So I get x squared equals 18, and you can see I end up in the same place. Okay, so I just find this easier to set up, so you can choose which way you do it. So now look at this one. We've got y, and we've got 2 and 5. So we have to think, what triangles are we dealing with? Well, we can see that we're dealing with this triangle, and if we are, y is the hypotenuse. Okay, but we're also dealing with the biggest triangle, where it would be the short leg. So, and this is the short leg. So now we know that we're using short leg and hypotenuse. But if you wanted to use the geometric mean model, there it is. Y squared equals 2 times, and remember you have to add these because the hypotenuse is 2 plus 5 is 7. So if I was setting this up, I'd go short to hypotenuse equals 2 to y, and that equals y over 7. So I've still got my geometric mean. I get y squared equals 14, and you can see that I get to the same place. Okay, so it's important that you figure this out, what method would work best for you. This is what I learned in Carnegie and the way I did it when I was a kid, so I like that method a little bit better. All right. Okay, so we're going to find the value of the variable. I am going to do both. So the geometric mean, this is the altitude method, the altitude theorem, and I would go x squared equals 6 times 19, so x squared equals 144, so x equals 12. Okay, for this one, I'm looking carefully. This is short and long legs. We're not talking about the hypotenuse. So it's going to be x, it's going to be short to long. And so I'm going to do x is to 16 as 9 is to x. So I cross multiply, I get x squared equals 144, and again, x equals 12. Okay, now we're going to go over here. What parts did they give me? So I could look at this as a long leg of the whole thing, and I think I'm going to have to because I'm given this and I'm not given any other parts to this triangle. Okay, so the two parts I have of the big triangle, so I have y as the hypotenuse of the medium triangle, this one here, and this is the long leg. And then for the biggest triangle, okay, the biggest triangle, y is the long leg, and this is your hypotenuse. So that's the information that I've been given. So I'm going to set it up. Well, we're going to do the geometric mean model. So the geometric mean, this is the leg theorem, is y squared equals 9 times, don't forget to add 9 and 2 together, so 9 times 11 is 99. And so we're going to go y squared equals 99, take the square root of both sides, y equals 3 square root of 11. Okay? So I'm going to settle, I want these to be your answers on the tests, so I'm not going to go any simpler, but if you were asked to on your homework, that one would be 9.95. Okay, so if I was going to set this up using my method, I would go hypotenuse to long, and then I would put my y as the hypotenuse. It is the hypotenuse for the red one, so I would put 9. And then the hypotenuse of the whole one is the 9 plus 2 is 11, and that's when my hypotenuse, or where y is the long leg, sorry. And so then we're going to get y squared equals 99, and we're at the same point, we will get the same answer. So hopefully you can see the difference between the two so that you can go on. Okay, so now we're going to use indirect measurement to find the cost of installing a rock wall. So first thing I'm going to do is I'm going to identify the geometric mean. It's 8.5. Okay, now I have to look at which two triangles I'm looking at. I am looking at the medium and the small triangle. I am not looking at the big one. So what I'm going to do is I'm going to set it up. So the geometric mean altitude theorem is right there, and it shows you how to set it up. So make sure you look at how the work is set up. And then if you're going to do it my method, you would go short to long. So you have 5 is to 8.5. And it's a geometric mean as long as it's the numerator on one side and the denominator on the other. Sometimes I write them backwards. So I've got my W. So then I cross multiply, I get 5W equals 72.25. Divide both sides by 5. And I get W equals 14.45. And then you would not forget to add the 5 that's down here. That's part of it right there. I used blue. So again, your answer is the same. Okay? All right. So if you are feeling confident, okay, these are two problems from your journal. If you want to do these, go ahead and push pause and give them a try. And then when you're done, we'll start up again and we'll give you the answers. Okay, so just so you have the answers, there you go. All right, so now you have your exit ticket. And this is number 1. You're going to find the height of the roof. And for this one, you're going to find the value of each variable. So don't worry about the A and B, just the 2 and 3. Okay, have a good day.